Okay, so you did a packet the other day when I wasn't here, talking about the mole. And it was leading you to be able to convert between how much you had mass, that you can weigh on a scale, and the mole, and the number of things, because in chemistry it's important that we be able to count things, but the atoms that we count are way, way too small to count, so we count them by weighing, like we had the beaker full of puffed rice, and we found a way to count the full beaker of puffed rice by weighing them, by taking the total mass of the puffed rice and the mass of one. We could do a little bit of math and figure out how many puffed rice we had. It's even a little more difficult with atoms, because they're so terribly small that counting them by hand is impossible, so we count them by weight, and we use the weights on the periodic table. Like hydrogen is 1.00794 grams per mole. So if we have the molar mass, that's grams per mole of something, we can calculate how many things we have. And we can start here by calculating. I have a sample of aluminum. It's just a sheet of aluminum that I have folded over to fit on the scale. Okay, so we can put it on the scale, tar out the weight, put it on there, and this weighs 5.54 grams. So I want to be able to take the mass of that 5.54 grams of aluminum, and I want to be able to convert it and figure out how many aluminum atoms are in there. So we have 5.54 grams of aluminum. And to be able to convert it to number of aluminum atoms, I have to first convert the mass into moles using the molar mass right off the periodic table. Then I can use Avogadro's number to convert it into number of things. Okay, so here, I'm going to use the molar mass of aluminum, which you'll notice right here is 26.98 grams per mole. That's the average atomic mass. It's just aluminum, there's nothing else bound to it, so I am going to convert using the molar mass of aluminum. I already have grams in the numerator, and I want grams to go away. I want to change it into moles, so I will say 1 mole of aluminum is 26.98 grams. I put the grams in the denominator so that they would cancel, and I'd be left with moles of aluminum. Okay, so I can convert the mass of my chunk of aluminum into moles, and then I can convert mass to moles, and I can convert moles to number of things using Avogadro's number. I already have moles in the numerator. I want them to go away, so I will put 1 mole in the denominator. Let's moles cancel. Is 6.022 times 10 to the 23 atoms or things. And then I can just get out my calculator and do the math. Okay. So I have 5.54 times 1 divided by 26.98, so divided by the molar mass of aluminum, and then multiplied by 6.02 times 10 to the 23, so 6.022 double E 23, and it tells me, oh wait a minute, I messed that up, so 5.54 divided by 26.98, and then times 6.022 double E 23 gives me 1.24 times 10 to the 23 aluminum atoms. Okay, so I can convert mass into number of things into a count, which is important in chemistry, because the central idea is being able to count atoms. All right, so do another example here. Get rid of all this. example here. I have a 2 kilogram chunk of steel or iron. So it's 2 kilograms, which is 2,000 grams of steel. I don't even have to put it on the scale. I have 2,000 grams of iron. I will convert that mass into moles using the molar mass of iron. The molar mass of iron right off the periodic table is 55.845 grams per mole. So 55.845 grams per mole of iron. So grams of iron, numerator, denominator, cancel. And then I will convert it to number of things using Avogadro's number. 1 mole of iron, 1 mole is 6.022 times 10 to the 23. My moles cancel. I just do the math. It'll tell me how many iron atoms are in this 2,000 gram sample. So 2,000 divided, so times 1, divided by 55.85 or 845 equal, and I will multiply it by 6.022 double E 23. And I get 2.157 times 10 to the 25 iron atoms. All right, so I weighed this. I weighed the aluminum originally. I divided by its molar mass of aluminum and multiplied by Avogadro's number to get the number of aluminum atoms. When I moved over to the iron, I took its mass in grams, divided by the molar mass of iron, and then multiplied by Avogadro's number to get the number of iron atoms in this sample. Okay? And it doesn't just have to be a single element like aluminum or iron. I can do the same math for compounds or molecules. Like here is a chunk of salt. So I will do the same thing. I will start with my grams of sodium chloride, and I will convert mass to moles and then moles to number of molecules. But I have to figure out how much I have here. And let me tar this out. Let me hold this up a little bit. I have a 2.51 grams sample of sodium chloride. 2.51 grams of sodium chloride. I have to find out the molar mass of sodium chloride. So it's 1 sodium and 1 chloride. Sodium is 22.989 grams per mole. Chloride is 35.45 grams per mole. So if you add those up, it's 58.44 grams of sodium chloride per mole. So the only difference here is it's not just iron or just aluminum, it's not just sodium or just chloride, it's the molecule, the compound sodium chloride. So, but it's the same type of math here. The grams will cancel, numerator and denominator. The moles will cancel, numerator and denominator. And I'll be left with molecules of sodium chloride. So, clear it out, and I have my chunk of sodium chloride is 2.51 grams. And I'm going to multiply by 1, divided by 58.44. And then multiply by 6.022 double E 23 and get that I have 2.586 times 10 to the 22 sodium chloride molecules. Okay, so that whole packet we did the other day was to be able to count how many things you have by weighing them. So you weigh the item, you would be converting to moles by dividing by the molar mass of the thing you have, and then converting to number of things by using Avogadro's number, by multiplying by Avogadro's number. And all the units cancel except atoms or molecules. And that's it. But what I'm going to want you to do now is you are going to write on a piece of paper somewhere. You're going to do this calculation, but this time you're going to do it for this chunk of charcoal, which is pure carbon. So you're going to have to look up the molar mass of carbon. If you don't have your periodic table with you, you can certainly find it online. So you're going to look up the molar mass of carbon. I'll weigh this carbon, and you are going to do the math. You're going to change the mass of this chunk of carbon into how many carbon atoms are in this. So you're going to find, I'm going to find the mass and give it to you. You're going to convert it to moles, then you're going to convert it to number of atoms. Okay, so let me clear this out. This chunk of carbon weighs 86.52 grams. So we have 86.52 grams of carbon. I want you to convert and tell me the number of carbon atoms. Write it on a piece of paper, do it in Notability or something on your iPad. Show me your work, show me how many carbon atoms you have, take a photograph of it, and submit that photograph on Canvas where it says, and that's all you have to do today, is tell me how many carbon atoms are in this 86.52 gram sample of carbon.